In this video, we will learn how to solve inequalities. If you recall, earlier in the chapter, we learned how to solve equations such as this one. When we solved these equations, we subtracted the number, the 5, since it was on the same side of the x, which allowed us to cross out the 5 on the left and subtract -2 minus 5 on the right, giving us an answer of x equals -7. What we're going to look at today is very similar, but instead of an equal sign, you're going to see the 4 inequality symbols: less than, greater than, less than or equal, greater than or equal. The difference here is that an equation with an equal sign gives us one potential true solution. X is equal to -7. That is the only value of x that would work in the original equation. When we're solving inequalities, we are looking for values that are greater or less, greater or equal, less or equal, which means there are many more possible solutions. In fact, there are infinite solutions to our inequalities. So we show that by drawing the number line to show that there are an infinite number of solutions to our inequality. Let's take a look at example number 1 in our notes. 5 plus x is greater than -2. We set up and solve this problem exactly the same way that we solved the previous one. The only difference is that in our answer we have a greater than symbol instead of an equal to sign. So what this means is that x can be any number that's greater than -7 to make that equation or that inequality a true statement. Numbers greater than -7 are -6, -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, and so on. We show that by drawing a number line because there is no possible way to write all of those solutions. So we're going to draw a number line, putting your solution in the middle. We're going to put 1 to the right, which is getting closer to 0, so that's a -6. And then we're going to write -8 to the left because that's getting smaller. Since this says x is greater than -7, that does not include -7 as a possible solution, and so we put an open circle on the -7 to show that it's not a solution, but that everything greater than -7 is a solution. So we draw or shade in our number line to the right. Let's take a look at another example. R minus 10 is less than or equal to -4. Solve this by adding 10 to both sides. This gives us R is less than or equal to 6. To draw a number line, put the 6 in the middle, 7 to the right, which is bigger than 6, and 5 to the left, which is smaller than 6. We're going to put a closed circle on the 6 this time because R is anything less than or equal to 6. And then we're going to shade the number line to the left of 6 because all the numbers less than 6 are to the left. Take a moment to try these two examples. Now we're going to take a look at some multiplication and division problems. As long as you are multiplying or dividing on both sides of your inequality by a positive number, your inequality symbol will stay the same, just as it did in the addition and subtraction examples. Let's take a look of what this looks like. 2x is less than -12. I'm going to divide 2 on both sides so that I can cross out 2 divided by 2, which is 1x, and -12 divided by 2 is -6. My number line would give me an open circle on the -6, and since I'm looking for numbers less than -6, I'm going to shade to the left. The second example is x divided by 5, so I'm going to multiply by 5 on both sides. This gives me a solution of x is greater than or equal to negative 5. My number line here will show me a closed circle above the negative 5, and my shading in this case will go to the right because the numbers bigger than negative 5 are to the right. If you notice that the numbers that I multiplied by on both sides were positive, 2 and 2, 5 and 5. What happens if I multiply on both sides by a negative? Let's use this as an example. If 4 is less than 7, then 4 times 2, which is 8, is also less than 7 times 2, which is 14. However, if I multiply by a negative 2 for both numbers, 4 and negative 7, I end up with a negative 8 and a negative 14. This is no longer the correct inequality symbol to go in between these two numbers. Negative 8 is actually greater than negative 7. When you multiply or divide both numbers by a negative, the signs become their opposite, which means which one is bigger also becomes the opposite. Let's take a look how this looks when we're solving an inequality. If you multiply or divide by a negative number on both sides of your inequality, you must flip the inequality symbol to its opposite. This first example should read negative 2x is less than negative 12. If it's not on your notes as a negative 2, go ahead and fix that so it matches this. In order to get x by itself, here we're going to need to divide on both sides by a negative 2. Since negative 2 divided by negative 2 is a positive 1, that gives us x by itself. Negative 12 divided by negative 2 gives us a positive 6. This is the case where, because I divided by a negative 2 on both sides, I must reverse or flip my inequality symbol to its opposite direction in order for my answer solutions to be true. The number line would show that any number that's greater than 6 would give a true statement. Open circle on the 6, arrow shading to the right. Let's just make sure that that makes sense. If I pick 7 because 7 is bigger than 6, and I plug that back into my original problem, let's make sure that that works. Negative 2 times 7 is negative 14, which is indeed less than 12. That is a true statement. If I accidentally forget to reverse my inequality sign to a greater than, then we're saying that anything less than 6 would be true. But if I plugged in a 5 into my original problem instead of a 7, negative 2 times 5 gives a negative 10, which is not less than negative 12. It's actually greater. So we need to flip the inequality symbol, because if we don't, the solutions that we're saying are true in the inequality are actually not true. Let's take a look at this next example. X divided by negative 5 is greater than or equal to negative 1. In order to get x by itself, we need to multiply both sides by negative 5. This allows the 5's to cancel as well as the negatives, leaving a positive x. And a negative 1 times a negative 5 equals a positive 5. However, because I multiplied on both sides by a negative 5, my answer must flip to a less than or equal to symbol. This would show a closed circle above the positive 5, and we would need to draw our arrow shading to the left. Here are a few more practice problems for you to try. Finally, negative 2/3 x is less than 6. In this example, we would need to multiply both sides by the reciprocal of negative 2/3, which is negative 3 over 2. On the left, the 2's cancel and the 3's cancel along with the negative signs, leaving us with a positive 1x. On the right-hand side, 6 and 2 can both be divided by 2. And finally, 3 times negative 3 is a negative 9. Since I multiplied on both sides by a negative 3/2, I must reverse my inequality sign to a greater than symbol, giving me x is greater than negative 9 as my answer. And I would put a open circle above the negative 9 and draw my shaded area to the right of negative 9. Take a moment to compare these examples and see if you can determine which of these inequalities would need their inequality symbol flipped to have the correct answer. If you said the top right and the bottom left, you would be correct, because the number next to the x is the number that you need to multiply or divide by, and if that number is negative, that is going to cause the inequality symbol to have to flip in your answer. Here are a few extra problems you can practice if you would like.